Assalamu alaikum. I'm Hamza from Mechatronics Department of Air University. This is Microcontroller and Embedded Systems lab. This is lab number 10. This lab is about PWM pulse width modulation. In this lab, we are going to control the speed of a bulb and the speed of motors using duty cycle. So our first task is to control the intensity of the lamp. So let's come to the task. PWM. So our first task is to control the intensity of a bulb using PWM pulse width modulation. So this is the code. So this is the code in which first we include the header file of AVR, then we define the CPU speed. After that, we include the delay file, delay header file. Then in int main, we set the seventh pin of port B as output. Then we have TCCRO register and we make the COM OA1 and WGM0 bits 1. Then we make TCCRO P equal to 0 cross 0 1 for no prescaler selection. Then we have while loop which displays OCRO A is equal to 0. Then we have do while loop like we have delay of 200 milliseconds. Then we have increment of 40 every time in the value of OCRO A while OCRA less than 200. So this is all about the code of task 1. Now come to its Proteus. Let's open Proteus. So this is the Proteus of this lab task 1 to control the intensity of the lamp using PWM. So let's upload the header file. Specify lab PWM. So here we have the hex file. We have uploaded the hex file. We connected the lamp to IO13, which is the seventh pin of port B as stated in our code. So let's run this. So you can see that the bulb displays first with low intensity and then its intensity goes on increasing. So this is lab task 1. Now our lab task 2. Let's come to the lab task 2. Lab task 2 is basically to control the speed of the motor using PWM. Let's open its C code. We have include header file, then we include the interrupt header file for AVR, then we include the header file for interrupt. We define the CPU speed, then we included the delay file. We set the duty cycle to 0. After that, in int main, we set the port D as output and port A as output. These are basically for the motors. Then we are using external interrupt mask register and make all the interrupts to 1. TCCROV0 for no prescaler, calling the interrupter CI command. OCR is equal to duty cycle is set to 0, then port A, and then port A, and then we have interrupt service routine for vector 0, duty cycle 20, then we are increasing. For vector 1, 2, 3, duty cycle is going to be increased. So this is our code. Now let's come to its Proteus. Let me open its Proteus file. So this is the Proteus of this code. So We are connected. We have connected the push buttons to port A using registers, and one side is ground, the other side is connected to power. So let's upload the hex file and see this effect on the speed of motor using PWM. So here we have uploaded the hex file. We have done okay. Let's run the simulation. So let's run it again. So when no push button is pressed, the motor is in steady state. When first push button is pressed, it is going to rotate very slowly. When other push button is pressed, sorry, it speeds up and then it runs speedily when all these push buttons are pressed. So this is all about our PWM lab, which is lab 10. For any query, you can comment below. So this is all about from my side. Thank you, Allah Hafiz.